that right?
8 minutes will be perfect presentation and 2 minutes for question. So if you present in 10 minutes, unfortunately we won't have time for questions.
All right, the interpreter is going to have to talk fast. All right, welcome everyone. I'm using Dutch Sign Language for this interpreter. I brought Zhangdan as my personal interpreter, so. Anyway, my name is Gomer, and I started building AI models a long time ago, and I tried to develop AI models for sign language recognition. I started last week with this, what I'm presenting today, so I'm really curious about your thoughts. I work for the University of Amsterdam, and I've been working there for the past 2 years. And I mean, I would like you guys to also be a bit more active because you've been listening all day. So just one question. This is the sign for T. Just try to sign with me. This is the sign for T. T. But with this sign for T, if you do it with your left hand instead of your right hand as your dominant hand, AI might have problems with that, even though it is the same sign. At the University of Amsterdam, we are working with a team of annotators, and we have 4,000 videos that we need to annotate. We have done quite a lot, but we still need to do 500 texts. We have this project called Zin in NGT, where we already have 2,000 sentences, and it is an app that for parents of deaf children, so that those parents can learn sign language through this application. So we show the glosses and the signs and connect that to the translation so that parents can learn the signs. And in total, we recorded over 185,000 videos in 2 years. We have 25 different cameras and a lot of different signers as well. And we mostly focus on sign language or on hand shape when we want to apply AI models. I discovered that AI models often only give one prediction. And the problem with that is, for example, the 5 hand shape or the B hand shape. There's only a slight difference with the spreading of the fingers. And if the quality of the videos is really low, then it's really hard to see. Sometimes you can infer what someone means just because of the context, but if the video quality is very low, then it's very hard to distinguish the differences between the 5 hand shape and the B hand shape. And another extra problem is that this is the most occurring hand shape in Dutch Sign Language. And this model overgeneralizes these signs. So that's why we switched to using softmax, the top 3, instead of just a top 1. We want to build a sign language architecture, but we also want to respect sign language linguistics, of course, because there has only been research on sign language linguistics for about 50 or 60 years, and we also want to take that knowledge into account when building our model. So we would like to train our model on these parameters. And this is based on information from the University of Surrey. They already built a lo-fi model, and we took that model and started expanding it. We use the sign collect annotation tool because it works quicker than ELAN. And as you can see here, you already get suggestions for the glosses. Just a second. You click on suggestions. There it is. So you get the predictions with those suggestions based on the hand shape, which is a way more efficient way of annotating. And with this, we also plan to add movement, location, and all the other parameters to make it even quicker. I have a question for you. Who knows HaMeR? HaMeR. Who knows this program? All right, I see a few people raising their hands. Then I think I'll leave this out. I mean, I have something just short to add about the HaMeR pipeline, because it works with detection too. And then you have fit pose. And with HaMeR, you can just take it directly from MediaPipe, and it's way quicker, double as fast compared to Detectron and FitPose. One of the limitations of HaMeR is when you interlace your fingers, then it becomes very distorted. I'm looking a bit angry in this when you look at me in this. I've also worked together with Oline on an algorithm, and it works on a Euclidean distance algorithm. It works, but it's not great. It's very, very slow, and every time we'd have to wait a day until we would get our results again. I'm short on time. Right. 2 more minutes, okay. So that's why we switched to XGBoost in combination with HaMeR. And that is how we get these geometric features. You can just read that for yourself. And we also have these data sets with about 13,400 samples. And with that, we have a training of 80% of the samples. And the science often starts like this. 25% of the time it starts with hello. So those data points we just neglected in this program. And the result is that 76.78% of the hand shapes are defined accurately. So it's so the model decides which hand shapes are put in classes together. So for example, in what angle it would be, how much the fingers are spread or not. In this confusion matrix, it becomes really clear where the hand shapes are accurately defined and where they're not accurate. In general, you can see this dark blue diagonal line where the accuracy is quite high. I'll skip this. So the problem is that we are using 2S-handedness data to train our model. So it doesn't matter if you are right dominant or left dominant, but if you use the sign, if you make the sign for coffee, it doesn't matter because you use the same hand sign. So with the 2S-handedness, we don't have the issue that we have with the sign for tea, because that uses 2 different hand shapes. Because the C hand shape could easily be mistaken for an S hand shape here. The problem is still that there are variations within sign language. So you could have one parameter be that the palm is faced up instead of down, and that would lead to mistakes. The last thing that I would like to put in here is that there's a new model called SAM 3D Body, and that might even work better than the systems that we had before. So it looks very promising. As you can see here, you can see the movements of the hands really clearly. And we're really out of time, right? I still want to show this quickly. This is motion capture, a default on the left. We have a motion capture lab, and then on the right, you see the new animation with HaMeR in combination with SAM 3D. Right, I guess that's it then. Then in summary, this in the middle, this new model, the SAM 3D model, we would like to use further in combination with WAN 2.2 video to create the picture on the right. That's it.
Thank you very much for your presentation. I'm afraid we need to skip questions. If you have any questions, please ask directly to Gomer. And yeah, now we can move to our last presentation to Tommy Fines. Thank you. Thank you again.